Today we're going to build on a new skill in code through a new kind of loop and a new skill in programming practice by talking a little bit about pair programming, which you'll get to practice in lab. Pair programming, unsurprisingly, is for two people to work together at programming. Typically, thinking of one keyboard hooked into one machine and one copy of the code. This provides the space for the two different people to do two different jobs, because these are important jobs for you to get used to eventually with programming, and you may end up doing them on your own, or you may end up doing them sort of asynchronously with people who do quality control or testing of your code or things like that. But you're actually doing two jobs often when you're programming. You're writing the code and creating those actual statements, and you're checking and evaluating whether that code is good, whether it meets the specification, and looking for possible errors as you go, proofreading as you go. But as you probably know from previous cases of even proofreading your own writing, it's often useful to have someone else observing and someone else checking, because they may notice issues that didn't occur to you or errors that you've made that you will just read right past and see what you wanted it to be, not what it actually is. So we call these two different roles the driver, the one typing, the one creating the code at the moment, and the observer, someone who's reviewing the code as it's typed, checking for errors, thinking about whether what's being done will feed in well to the overall design of the program. So there's reading that you need to do about pair programming to dig deeper into these ideas, but I'll give you a few details about the steps in pair programming. First, it's important to have already done your design and to sit down with a well-defined task that you are taking on as a pair. You should have already done some specification on what the problem is. You should have already thought through some use cases. You should have already made a design that you're now just implementing. You then agree on one little goal from that design at a time. We're going to write this function. We're going to work on this portion of a function, those sorts of things. And then each of you should be relying on your partner and at the same time supporting your partner. You each have roles to do. The driver, for example, should check in with the observer to ask about if they're uncertain whether something seems reasonable or clear or meets the specification. And likewise, the observer should rely on the driver to do a good job of implementing things, but support them by pointing out things that are known issues that they recognize as an issue. It will require a lot of talking and a lot of syncing up to make sure that you're on the same page of what's being done at the moment. It's easy to just sort of watch the code go by and lose track of where you are in the design or where you are in the grand scheme of the program that's being written. And you have someone to enjoy the accomplishment with, and you should take some time to make note of what things you've gotten done, check things off your to-do list together, and be proud of the times that you overcame some problem that arose. You thought through a tricky situation rather than making the mistake that might have gone with not noticing it or not thinking through it. And you should switch roles often so that you're both getting experience at both jobs and so that it's keeping you sort of both alert, because it's easy, especially in the observer role, to get bored or to lose interest or start to assume that the other person is just going to get the job done. And so it's important to switch out on those different roles fairly frequently. Not so frequently that you're constantly losing track of where things were, or that the other person is now changing the way that the first person did things because that way doesn't work naturally in their mind and they want to try a different approach all of the time. Sometimes that's important to do, but it should be done sort of collaboratively, not with some rigid switching that is unproductive for you there. There are lots of really good collaboration tools for software as well. We may not use all of them in this class, but it's good to be aware that these kinds of tools exist, and they're actually a very important part of how software engineering is done, because software engineering is rarely done alone. Often, code is done in teams where some person's code feeds into or connects with another person's code, and often even when it was done alone originally, it may be shared out to other people in ways that they may want to be able to collaborate and cooperate with those other people. So we've seen packages in Python that is code that's sort of packaged up so that people can import it and use it. And those are something that requires a lot of collaboration to make sure that that package actually does a job that's useful and does it in a way that others are going to benefit from. Not just the one person who wrote it and nobody else ever uses it. If you write code like that that's not reusable by others, eventually you're going to lose the steam on maintaining it. And if you write code that's shareable and reusable, other people will want to use it and share it and help to maintain it and add features to it. This is especially important in open source kind of systems or research systems where you're sharing your code with other researchers. One of the tools for sharing code is version control or repositories. You can store your code in a place where the team can access it as just a repository. Google Drive or things like this work well for just uploading stuff and making it accessible. A website can be a perfectly good repository. But there are also systems for doing version control where different people can be working on the same package of code at the same time. And when they go to upload, there are good systems for tracking which files got changed, which changes might conflict with each other, and finding ways to merge or reconcile those. And these can be really, really important in software teams and, again, in open source settings where lots of people have different needs but may want to come together to be working on one shared product. And pair programming is just another collaboration tool. And you may use some of these other collaboration tools, or yet more ones that we won't talk about, in doing pair programming well. A note before we transition is to talking about loops, is to talk for a moment about input. Because one of the things that's quite often done in loops is getting user input. Asking the user to type in something so that you can use that in the execution of your program. Login prompts, choices of menus within the program, various things like that can be done using user input. Since our programs so far are primarily text-based, then we'll talk a little bit about text-based user input. So when you do an input-seeking command, the program will pause execution and wait for the user to enter a response. This can often confuse programmers, and they think that their program is hanging and doing nothing. This is part of why it's important to give prompts and messages that make it clear that the program will be running or will be waiting for user input. And so you can see in the input example down here, which is a built-in Python function that will get user input, you can provide what the prompt is right there on the spot. So it will say, please enter a number, and then it will wait until the user enters something and hits the enter or return key. In Python, the value you get back from input will always be a string. It will always be treated as text. And that's because the user could type in any kind of text that they want at the line, and Python wants to handle this gracefully. So then your job is, if needed, to turn it into the kind of data that you want it to be. If you want it to be an integer, then you can use the built-in int function, which converts a string or other data into an integer. If the data that was given to you is not a valid integer, you will get an error on this line. So it may be a good idea to check first whether what you were given will be usable as an integer. And this is where looping can come in handy, to be able to loop until the user gives you a valid input type. And here, once we've converted it to an int, then we can do math with it and we're just fine. Often, beginning programmers will forget this step in Python and try to use the string version, and that can cause problems. You will sometimes see examples where others have used the eval function to try to convert something to be an integer or a list or whatever. This is very dangerous in terms of the security of your programs, because eval will take whatever your user gave and execute it as code. So if your user gave the code to delete all files on your file system, your program may execute that and actually delete all files in your file system if you use the eval function. So be careful about your use of those sorts of things. It's really best to know what type of data that you're actually wanting from the user, confirm that you've gotten that type of data, and then use the function that converts directly to that type, like int. So we've talked already about a few different control structures or control blocks in Python code. The default is for code to be executed one line after another. And this is what we've seen in most of the very, very beginning examples that we saw. We create a variable. We do some math with that variable. We print out the result of that math. These are all done one after another. But since then, we've learned some control structures that allow us to change that line-by-line style of execution. The two that we've seen so far are for loops, which allow us to take that, and instead of going line by line, we sometimes loop back up to the top and repeat the chunk of code that's indented inside of that for loop. And we've seen if statements, which instead of always going line by line, sometimes they skip a portion of code if the condition for that portion of code is not met. Now we're going to see another control structure, a while loop, which is similar in some ways to a for loop, but varies a little because they're designed essentially to run indefinitely except when their condition stops being true. So you can, for instance, get a while loop to run forever by simply saying while true or while 3 equals 3. Those will always be true, and therefore that while loop could run forever if the program was allowed to and the computer kept working, and so on and so on. So you can read the statement of a while loop as while something is true, do the block inside of the while loop. This means that it's very important to be careful when writing a while loop. It won't automatically step to the next value or things like that, like a for loop will. You have to make things change so that the condition of the while loop eventually stops being true and the program can finish executing. Here's a fairly basic example of a while loop. It uses the condition that n is less than or equal to 10, and the program starts out n equaling 0. So here it's printing n, and then it's increasing n by 1 and storing that value again as n. So this will start at 0, print 0 because 0 is less than or equal to 10. Then n will get increased and will come back around. This behavior here is actually pretty similar to a for loop. In fact, a for loop sort of condenses this down into 2 lines instead of the 4 lines we see here. We define a range, and we don't have to say n equals 0, and we don't have to say n is less than or equal to 10, because our range will do that. And we don't have to increase n by 1, because our range will also do that. So in this case, this while loop is sort of just a for loop stretched out to say all of the pieces of what's happening. There's a few things that I want to point out about it, though. We could do more interesting things with n. For example, square it every time instead of adding 1 to it, or things like that might change the pattern of what the values of n actually end up being. Another thing that I want to point out is that we can do other things in terms of the condition. We could use negative values inside of that condition or various other things like that that might be difficult to do with the built-in for loop style. We also are subject to way more possible errors. We might accidentally start n at the wrong value. We might also, and this is very common, forget to increase n by 1 inside of the while loop. If we forgot to increase n by 1, n would start out as 0. 0 would be less than or equal to 10. We would print 0, and then we would loop back, and we would have 0 is less than or equal to 10, and print it, and loop back, and so on forever. So again, it is possible for a while loop to continue forever functionally, as long as the program is running and the computer is running. Here's another example where we've changed how that number starts and how it changes throughout the loop. So we have m now. We set m to 1 to begin with, and we're saying m less than or equal to 100. So this part is still similar to a range because we could define a start and an end. But we're saying now m equals m times 2. So you can see we're able to control how the step part is done, how we step a little closer to that value of 100. And we'll see even more examples of how while loops can be very powerful for doing much more complex step types. Though Python's for loops are pretty versatile in their style as well. So this leads us to often ask the question of which control structure we should use. We'll learn more and more of these kinds of tools, and we'll end up in situations where there's multiple ways of doing something. For instance, we could use a for loop or a while loop to do that particular thing. And often, this is something that you'll just have to balance out, the different features. The for loop, for instance, may be more readable in one case, or it may be less subject to making errors and therefore have fewer bugs if we use the for loop. But there may be a case where we get so stuck on using for loops all the time and they become so familiar that we end up writing something that's very, very complicated and unnatural to try to, for instance, rewind our range to get back to a previous value in a way that a while loop could pretty naturally do, or things like that, that we should avoid. So it's best to think about the programming language, think about the actual problem you're approaching, and think about all of the structures that are available to you, and try to make sure they fit. And this is a somewhat subjective thing, and this is something that you'll have to get more experience with over time. Many beginning programmers get very fixated on one small subset of control structures, and they miss the opportunity to use ones that fit the situation a bit more naturally and might be more efficient, or might be easier for another person to come in and look at your code and read, or for you to look at your code later and maintain or debug. So let's revisit each of those control structures in a little more depth. A for loop considers everything in a list or a range of things. You can run a group of statements a predetermined number of times, so we can determine how many times we want something to run, and this could be based on user input or things like that, but it is predetermined before the for loop starts. If another value exists in the sequence, all the statements are run once, and then the next value in the sequence is checked. So we execute the full body of the for loop, and then we move on to the next value in our list or in our range. A while loop is similar in that we can run a group of statements repeated times, but we run until a particular condition is no longer true. For example, if a network connection dies, or if the user has entered the word exit, or things like that, a while loop can be very useful for testing that kind of condition, because the condition is tested every time. If it's true, then all the statements in the while loop's body get executed, and then that condition is tested again. Did the user enter exit yet? No. Okay, keep going. Did the user enter exit yet? No. Keep going. And when the user entered exit, then our condition is false, whatever our condition was. Input is not equal to exit, for instance, and our while loop exits. This is much easier than trying to use a for loop somehow to achieve that same goal. An if statement, on the other hand, does have a condition, and that condition allows us to choose whether or not to run a group of statements, or to choose between a group of statements, choose between two groups of statements to run in the case of if-else, or choose between multiple groups of statements to run in the if-else chain. But an if statement only executes its body one time, if that, one or fewer times. Comparing a little further, a for loop versus a while loop, we have for I in range 1 to 5, print I. That is legal. That will work perfectly well. It might make sense to write while I is in the range 1 through 5, but that is not the right way to write the condition for a while loop. We need an actual comparison or an actual Boolean statement, a true or false statement there, such as while I is less than 5 and I is greater than 1, or that sort of thing, or greater than or equal to 1, that sort of thing. So don't try to write a while loop as if it were a for loop. Another thing that we'll commonly do in a while loop is have some sentinel value, or sort of a watch value. That's what sentinel means. We can use that special value to make our loop keep running forever until a condition that's tested inside of the loop changes or looks the way that we want it to. So this is a function for determining if a particular secret has been provided to us here. So we want to get this secret from the user, and we want to not allow them to enter empty text. Otherwise, they'll be re-prompted. So we start out with our keep going condition, which is a sentinel or a watch value set to be true, so that when I come down to the I misstated something. When I come down to the loop, keep going will be true, and so my while loop will enter. This actually keeps going until the user enters an empty string. I got that wrong a moment ago and misstated that. So it asks for the next secret by prompting the user, tell me a secret. If the next secret is the empty string, that means the user's done providing secrets, and we set keep going to false. Now the loop does not quit right at this line, but it does quit very soon after, because my else will not execute down below. And so it will skip the else part, and it will flip up to the top of the while loop. It will check the condition, and it will find that keep going is false, and therefore the while loop will exit and my function will be done. Hopefully I will have returned the value or done something with it at the end afterwards, but right now we're caring about the while loop. So if the user did input a real secret, which is any non-empty string, then we won't set keep going to false. It will stay true. So we'll hit the else and we will add to our my secrets list down here. And then we'll loop back around. From there, keep going is still true, and so we ask for another secret, and if that is not an empty string, we'll add to our list of secrets and we'll loop back. And we'll continue doing this until the user hits enter with nothing typed, therefore providing us the empty string, and we will set keep going to false, and that will be our last time through the loop. And then the function will exit. So this allows us to hold on to a value that tells us whether our while loop should continue or not. So remember that while loops provide us this new control structure where we can keep a loop running until the condition that the loop is set with becomes false. In other words, it will keep going as long as its condition is true. As long as there are people left to pick for our teams, we will keep going in the while loop that picks the next person for a team. As long as the user has not told us to exit the program, we will keep going in the loop that asks the user for commands or things like that. And this kind of structure is very, very common. It serves a different purpose than a for loop, though we often kind of get to pick, and we could translate from one to the other. It might be more or less natural to use a while loop versus a for loop in a particular situation, and it's up to you to determine those situations.